Hello and welcome to our latest screen recording. I am on page 231 in our book. We went through this in class. This is just a review video for you at home. If you are having any questions on the homework 6-1 today. We talked about cubes and how they have 6 faces and 12 edges. Edges are where two faces come together. And all of these would count as edges. The vertex here are the points, and that's where 3 or more, and it's only 3 in a cube, but 3 or more faces come together. That would be our vertex. I've seen vertex as vertices and vertexes, so you could see it all either way. Our next page here, we ended up making and constructing these rectangular prisms out of cubes, so we were able to find the volume of those. So we talked about how when finding the volume of a rectangular prism, we do our length times our width times our height. We actually constructed them and found that there were 8, 16 with 2 layers, 24 with our third layer, 32 with our 4 layer, and so on. We constructed each one of those all the way up, and then we're able to count the cubes. But we don't necessarily need to count the cubes. We can always multiply length times width times height. We also talked then about cubic centimeters and how we could write, and it could be any unit, how we could write those cubic centimeters or centimeters threed. 3 stands for cube, so 8 centimeters cubed. We then developed our formula, and that's where we learned about length times width times height. So length times width times height. We also talked about the commutative property, how we could go 5 times 2 times 3 if we actually were to follow length times width times height, length, width, height. But we learned that we could multiply them in any order. 5 times 2 is 10, times 3 gives me 30, 2 times 3 is 6, times 5, so 6 times 5 is 30. Either way, we're going to get 30 centimeters cubed for our volume. Next page, we talked about solving a couple problems using our length times width times height, and then our volume in centimeters cubed. This 16 was a little tricky because they used 1/2, so we did 3 times 2 and got 6. 6 times 1/2 was 3 feet cubed. Sometimes they're nice, they go straight across and we can multiply them in our head. Sometimes they're bigger numbers like 2, 8, and 6. So we did 6 times 8 and got 48, and then took our 48 times 2. We're able to get 96 units. Number 18 was 24 faces on the inside. If we were to split those apart, there would be 24 unpainted faces. Then we got into our homework, and it's quite large right now. We did one example together. We also wrote that volume is length times width times height, so that should be on your child's paper. And then we did number 5 together, where we were given 2 of the sides, 4 and 5. So we found out that the base was 20 cubes, and we then knew once we had the base of 4 times 5 is 20, we knew that we had to figure out how many cubes, how many layers it would take to give us 200 cubes. So we did 20 times what gave me 200 times 10. We then checked it with our base, our length times width times height, We checked it with base, our length, width, and height, and we did get our 200. The review side is where we had a little struggle in class, so we'll kind of go over this a little more in depth. For number 1, 2, 3, and 4, you're going to need 3 different fractions that are equivalent. So you can multiply by any number. You'll notice we took our 2/3 times 2 and got 4/6. We took our 2/3 times 4 and got 8/12. We took our 2/3 times 6 and got 6/18. You might have had a different one in class with me because I just took multiplication problems from different students and what they wanted to multiply by. So those are 3 options. You could have multiplied it by any 3 numbers, and you'll do the same for those. Numbers 5, 6, 7, 8, you need to add or subtract the fractions. You'll notice right away, and we did one together, that we do not have common denominators for any of these problems. So you need a common denominator. In the case of number 5, we picked 15. So 2/3 became 10/15 timesing 5. 3/5 became 9/15 timesing by 3. We added them up, 19/15, simplified it to 1 and 4/15. Number 9, we're finding the area. The area of this parallelogram is base times height. So base times height will give you that area of that flat parallelogram. Number 11 and 12, we crossed out 1 decimeter and changed it to 10 centimeters. For Minnesota testing, we don't need to worry about 10 centimeters equals 1 decimeter, so I gave them that freebie. And then we had to find the perimeter around the outside and the area. Now the area for this one is a little different. It will be base times height divided by 2 because it's 1/2 base times height. Lastly, 13 through 15 are the factor puzzles that we love so much. Find a common multiple of these two, find the common multiple of those two, work your way around and end up with our middle number. In fact, I think I'll go ahead and do this one quickly here on the video. So 6 times 4 is 24. 6 times 7 is 42. So 6 is our common factor there. 4 here. 6 times 4 is 24. 4 there. 7 times 6 is 42. 7 over here. Then we look at our 35. 7 times what gives me 35? 7 times 5. So 5 times 4. My missing number is 20 when I work my way around the factor puzzle. I hope that helps. Have a great night.